So the first thing we always want to do every time, decide what our population is and what we're calling success. So it says here we're looking at the proportion of voters who prefer candidate A. So the first thing we would write down is our population. Change my view here. So our population is voters. Remember, population is a group, not a number. Success, prefer candidate A. A. That helps us to write this. This is the line that's required. Those two you don't have to write down, but people that write those down are much more likely to get this line that is required on written assignments correct. Let P, the thing we're making predictions about, be the proportion of them that do that. The proportion of voters, the population, that prefer A. Because we're going to write all these hypotheses, and hypotheses are complete mathematical sentences. And unless we know what it is we're talking about, we're going to have P's all over the place. Unless we know what P means, we're not making complete statements. And it makes it much harder to interpret our answer. Writing this line makes it much easier at the end to write our final answer. Okay, we think we know P. We think it might be 37%. So they've already written hypotheses out for us in this example, but let's say they haven't done that yet. We're going to actually figure that out. We think 37% P equals 0.37. We think 37% of these did that. But then we do a sample, and the sample is going to say, oh, no, you're wrong. It's actually less than that. Okay, so we call this number here P naught. P naught is the number we believed before we did the sample. So let's put that over here. We think P is P naught. Our calculator is going to ask us for that in a minute. So we need to know what number P naught is. Okay, then we look at our sample. So remember, we're always going to have an X, an N, and a P hat every time. They're always going to give us N every time, and then they'll give us one of these two. And we have to figure out which one is which. X is a whole number. P hat is a decimal. It's a percentage. So 143 successes out of 482. So that's the number of people in the sample that support candidate A. That's the number of people in the sample. It's their sample size. X is always the number of successes in the sample. You should have that written down several times now. N is the sample size. P hat is always X over N. So let's get out our trusty calculator here. Out of, I think it was 482. Let's call that 2967. I'm going to round to several places here. $143 and 4. Did I type that right? 482. That is significantly different. We may need to check the code on this question. That is very different. We thought 37% support this guy. We get a sample, and the sample says that's actually less than 30%. That's like almost an 8-point difference there. That's a big difference. Okay, now we read the question. We want to see, right here, I'm looking at this part, if the proportion P is less than 37%. So we're going to write our two hypotheses. So this is what we are testing against. This is what we believed before we did the sample. That's that P naught right there. And then we're always going to use the same number here. This number here only tells me whether to write greater than or less than. I never ever write this number in the hypothesis. P is less than 37%. How do I know to say less than? Well, because 29 is less than 37, and the question said here, less than 37. It was right in the words. You got to look at both. Okay, now we could do this by hand, and a lot of the videos, remember, I didn't record all these videos. A lot of these videos will probably show you how to do it by hand. And if you want to do it that way, it's perfectly fine. But we've got this fancy calculator that has all of our buttons on here. So let's just use the calculator. Okay, let's write this down. Our alpha level is 1%. And now let's use our calculator. Remember, for the next week or so, the only buttons you'll be using are 5, 6, A, and B. So I go into Stat, over to Tests, and I'm looking for, first, our button better say proportion. Everything on test 3 is proportions. If your button doesn't say prop in it, you're doing something wrong. Secondly, are we doing an interval or a test? This is a test. We're doing a hypothesis test. It's right in the name. So I don't want a button that says interval, like look at number 9 there. It says INT. That's for a confidence interval. I want a button that says test. Okay, let's look at button 6. Look at that. It's asking for X1, N1. I didn't write down, no place on this page did I write down X1, N1, all that stuff. I only have one sample here. That says 2 prop test. I only have 1. That's not what I want. I want button 5, 1 prop test. And notice that it has exactly the same stuff I just wrote down. P naught. P naught was the 0.37. X was 143. N was 482. And then which hypothesis did we write? What did I write here for the alternative hypothesis? I put P is less than P naught. So I want the button that says less than P naught. So I wish the calculator wrote this out a little differently. What the calculator is writing is they already have this part right here. HA is P blank, and then this is what you're choosing. So I'm choosing less than P naught. I hit calculate, and that's going to give me a whole bunch of information. It's going to give me my P naught. No, so give me my P hat, my sample statistic. I wish the calculator here would make this a capital P, because that's our P value. That's our probability. And it gives us our Z-score. That's what we call the test statistic. So let me write all this down. The test statistic is the Z-score, and it was -3 something. 3.33. We want to go at least 2 places on a Z-score. Our P value, that stands for probability. That's a capital P. 4.28 times 10 to the negative fourth. Look at that e negative 4 there. It's a very, very small probability because that's a big giant z-score. Okay, now here's our alpha level. That p-value is tiny. That p-value is much less than the alpha level because that's smaller than 0.01. This is 0.000428. If you're less than alpha, you reject. Say that to yourself 100 times. Less than alpha, reject. Less than alpha, reject. Small probability is very strong evidence. It's counterintuitive. We tend to think high probability means something happened. What we're looking for here, imagine we did a DNA test on somebody. We're conducting a criminal trial. And I think I have the killer. I went out and I did a DNA test and I get my p-value. My p-value in this context is not the probability that that guy's the killer. This is the probability that that's somebody else's DNA. That's what we're calculating here. What's the probability that somebody else did the murder? Oh, it's very small. That means that guy must have done the murder. We're calculating the probability of getting this sample if the null hypothesis is true. In fact, up here, we should draw a picture. This is what our model's based around. So right in the middle, we've got P naught, which was 0.37. Way down here was my sample. And I shade below. We're always going to shade a tail here. Sometimes both tails. Okay, so my p-value is very low. That means we reject the null and accept the alternative. The only possible things you can write here, there are only two things you can write: reject the null and accept the alternative, or you can write fail to reject the null. We never ever accept the null. That's not allowed. Just like with a criminal trial, somebody goes on trial, they're either found guilty or not guilty. They're not found innocent. Like OJ was found not guilty. We all still think he did it. We know OJ did it, but they didn't prove he did it. So when he was released, nobody said, oh, well, we've proven him innocent. No, they failed to prove him guilty. So we think we know some population proportion. We find evidence that says, hey, that thing you think, it's probably wrong. We're trying to see if we have enough evidence to prove it's wrong. That's our goal. Prove the null hypothesis false. And we either satisfy that, we have enough evidence to prove it's false, or we just didn't have enough evidence. We still think it might be false, but we don't always have enough evidence to prove it's false. Never accept the null hypothesis. Okay, so we reject the null and accept the alternative, which means we're going to write this sentence every time we have strong evidence that. Well, what does the alternative say? What's this say in words? Well, it's a good thing I wrote down P here. The proportion of voters that prefer candidate A is less than 37%. So this is what a complete sentence will look like. Literally everything I've written here, other than putting these boxes around here, everything is that you see here is required for a complete written solution.